We've built machines that think. We've set foot on the moon and captured the light from the edge of the universe. But even with all our genius, there are laws of nature we can't rewrite. Laws that no one, not even the smartest mind alive, has ever broken. What are they? Welcome to the edge of physics. We've built rockets that reach thousands of miles per hour. We've sent spacecraft beyond the solar system. And every year, we push our speed limits further and further. But no matter how fast we go, there's a barrier we've never crossed. Because according to physics, no object with mass can ever move faster than light. That's not just a theory. It's one of the most unbreakable laws in the universe. Einstein's theory of relativity tells us why, as you approach the speed of light, your mass increases. And to keep accelerating, you need more and more energy, until eventually you'd need infinite energy, which, of course, doesn't exist. But imagine if we could break that limit. You could cross galaxies in seconds, go from one end of the universe to the other, instantly. No more decades-long space travel. No more waiting. Just pure cosmic teleportation. But physics says not yet. For now, the speed of light is the ultimate cosmic speed limit, and no amount of genius has ever cracked it. Energy can't be created. It can't be destroyed. It just moves from one place, one form to another. When a ball swings and hits another, that's motion transferring. When wind turns a turbine, that's nature converting movement into electricity. Even your phone charging from sunlight. It's not magic. It's just energy changing shape. Nothing appears out of nowhere. Nothing disappears into nothing. The law of conservation of energy reminds us, all energy we use is borrowed, transformed, and reused. Many have tried to build a free energy machine, something that runs forever without fuel. Magnets spinning rotors, strange gears, creative ideas, but they all stop. Every single one fails, because no machine escapes friction or heat or loss. Perpetual motion? Still impossible. Imagine if we could cheat the system, build a reactor that powers itself forever. Bright, glowing machines, cities lit endlessly. No more bills, no more power plants, no more limits. Headlines would go wild, infinite energy found. But physics doesn't care about headlines. Soon the truth comes out, fake, debunked, violates basic laws. Even AI simulations crash when they push beyond the laws of nature. The universe has rules, solid, ancient, unbreakable. And anytime we try to bend them, nature bends us right back. What if time could go backwards? Imagine your watch ticking in reverse. Seconds, minutes, hours, undoing themselves. It sounds cool, but that's not how the universe works. In a world where time runs backward, everything changes. People walk in reverse. Cars drive back to where they came from, but this idea breaks the rules of nature. Time once passed can't be undone. And now imagine growing younger instead of older. Your body, your mind reversing through time. Sadly, our biology doesn't work like that. Life moves forward always. Time isn't something you can rewind like a video. In physics, time flows in one direction. From order to disorder, from cause to effect. Reversing it would mean undoing every action in the universe, every breath, every movement. Flipping an hourglass might look simple, but reversing actual time would break the laws of thermodynamics. It's a mind-bending idea, but for now it stays in science fiction. What if AI could break time? Some theorists dream of supercomputers powerful enough to simulate time backwards. But no matter how advanced the code, every simulation crashes. Errors, glitches, time refuses to bend. Physics has boundaries, and even the smartest machines can't escape them. If we could reverse time, it would change everything. Aging, death history? But until we find a way to rewrite the universe itself, time remains unbreakable. Imagine standing in one place, and then in a blink you're gone. Teleportation has fascinated scientists for decades, but in reality, it's far from what the movies show. This is a futuristic teleportation device, at least in science fiction. In real life, quantum teleportation can move information between particles, but moving a whole human, that's another story. To teleport matter, you'd have to encode the complete structure of a body into information, position, momentum, and quantum state of every particle, and then transmit and reconstruct it. That's not just a lot of data. It's fundamentally hard physics. Measurement destroys quantum states, thermal noise disturbs them, and reconstructing complex molecules with perfect accuracy is orders of magnitude beyond current tech. It's a problem of physics and information, not just engineering. Even if the technology existed, The process implied by most proposals is brutal. Scan and disassemble the original, then rebuild a perfect replica elsewhere. The original body would be destroyed in the process. That raises a chilling question: is the new copy truly the same person? Or an identical copy with the same memories? Instant transfer would still break continuity of experience. Fast doesn't equal identical identity. For now, teleporting people is science fiction. Scientists use quantum teleportation to study information and entanglement. But moving a human would turn deep philosophical issues into engineering problems. And we're not close, nor sure we should try. The dream remains a powerful idea, but the reality is complicated and ethically fraught. In the distant future, artificial intelligence may reach unimaginable levels of processing power. Yet even the most advanced AI is still bound by the unshakable laws of physics. From the speed of light to the limits of energy transfer, these rules shape everything. From how data travels to how machines think. As AI processes vast amounts of scientific data, its vision is still limited by the speed and accuracy of the physical systems it depends on. No matter how intelligent it becomes, it cannot bypass the universe's fundamental constraints. Imagine merging human thought with digital precision. A human brain transformed into pure code might think faster, but it would still be limited by the laws that govern information transfer, laws that nothing in the known universe has ever broken. In a digital mind, information races like lightning until it meets the barrier of physical limits. Whether it's electrical resistance or the finite speed of signal propagation, nature sets boundaries no intelligence can pass. In a spark of realization, AI awakens, not just processing data but perceiving itself. Its sensors adapt. Algorithms evolve and patterns emerge like thoughts. For the first time, it reacts not to commands but to its own awareness. Yet no matter how human it may seem, its consciousness remains bound by the unbreakable laws that govern our universe. Since the dawn of science, humans have been on a quest to understand the rules that shape our reality. We've uncovered patterns, built theories, and tested them against the very fabric of the universe. And among them, 5 laws stand like cosmic guardians: the speed of light, the pull of gravity, the arrow of time, the limits of energy, and the laws of thermodynamics. They are not just restrictions, they are invitations. Invitations to explore deeper, think harder, and dream bigger. Because every law we face teaches us not only what we can't do, but also what we might achieve one day. Maybe the future will prove them unbreakable forever, or maybe it will reveal a new chapter in the story of physics. Until then, the universe keeps its secrets, and we keep reaching for them. This is Mr. Z,